to GTC Taiwan. So great to see all of you. Very good to be home. I brought my parents home. Where are my parents? Everybody give a round of applause to my mom and dad. And a round of applause for our pre-game show superstars, ladies and gentlemen. Look how adorable they are. The superstars of Taiwan. There are so many of you here today. We are broadcasting this right now to 70 other watch parties across Taiwan. 70 different conferences are going at the same time. Everybody is watching this keynote. We have so much to tell you, and I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There's so many people to thank. I love my ecosystem here. I mean, there are so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem, the richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was agentic AI. And today, we can say that agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up, okay? And so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion, that $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired, and the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, why wouldn't you want to hire more software engineers? If that line was flat, then obviously people will hire fewer software engineers. But because the output is so incredible, people want to hire more software engineers. This is going to show up in our economy somehow soon. And so the first thing is useful AI has arrived. Now, what does that mean from the industry's perspective? From the industry's perspective, that means that tokens are now in extraordinary demand. Because if you could do this, you're going to want to produce more of it. And because tokens are now profitable units, tokens are now profitable units of revenues. Because it is now profitable, the AI companies want to build a lot more tokens, generate a lot more tokens, build more AI factories, which is the reason why compute demand here in Taiwan has skyrocketed. It is precisely the reason why all of you are so busy and your businesses are doing so well. In fact, that looks like some of your stock price. The compute pattern has changed. Everything has changed. So the first idea is that useful AI has arrived. AI is now a profit generator. AI is now a GDP generator. Behind it is a whole new kind of computing pattern. Not just a large language model, but an agent. Today, almost everything we're going to talk about is going to be based on this. So let me take a quick moment and show you what I'm talking about. This is an agent. It's an agent application. In the old days, this would be application, this would be code, and this would be operating system. Application, code running inside an application, inside an operating system. Today, it is agent, which consists of a large language model, or many, sitting inside a harness, and that harness helps it, orchestrates it to do productive work. This is the input. When that input comes, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrates this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we do, we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It could do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated. and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but COMPUTEX does an incredible job as well. Here's another example. This is the input. Create a GIF, NVIDIA green dots on black scatter, form Taiwan 101 building, morph to GTC Taipei 2026, morph to NVIDIA I logo, then scatter and repeat, right? So you saw that. That was the prompt. Here's the next one. I lost my remote control battery clip. It looks like this. Create a CAD file. It uses a tool. Create a CAD file, ready for 3D printing to create a new one. Make sense? This is now the new computing pattern. Whereas we used to launch an application, click and type, we now replace that with explaining to the AI what we want, our intent, and the AI generates the code or uses tools and produce the necessary output. This is how computers are going to work in the future. This is agentic AI. For 2 years, we've been building towards this, and now it has arrived. Now, one of the big breakthroughs, of course, is tool use. A lot of people have said, you know, Jensen, AI is coming, agentic AI is coming, therefore all of the software companies are going to go out of business. I said it's exactly the opposite. Because there are going to be so many agents, the world is no longer limited by the number of people. Therefore, those agents are going to use more tools than ever. This is actually an incredible time to be a software company. But the software has to be presented to the agent in a way that the agent can use it. This is a big breakthrough, and in fact, what we have done, as you know, what NVIDIA's treasure is all of our CUDA libraries. I call them COMPUTEX libraries. This is NVIDIA's treasure. Today, we're able to now present these COMPUTEX libraries to agents who can use it much more effectively than even humans. And so this is a wonderful time for COMPUTEX libraries. Let's take a look. The computing pattern of software is going to change. In fact, let's come back to this. This is the agent. It is the ultimate disaggregated and distributed computing model. So many different computers are going to be activated in order to process this agent. The agent consists of model, harness, tools and skills, and a runtime. All of that is running at different places in a data center. You can think of the model as the brain, the harness as the body, the tools that it uses, working in a runtime, think of it as a workshop. So this is a person, a worker, working with tools in a workshop. Of course, this is being done at extraordinarily large scales. And each one of those steps are running in a different part of the computer. And you could see the large language model is thinking, context processing, observing, understanding the environment, reasoning, coming up with a plan, and acting on the plan. Every single time that happens, an entire rack of Grace Blackwell NVLink 72 is activated. It's thinking with the large language model. Whenever it uses a tool, a CPU is used. That tool could be a C compiler. It could be Python. It could be JavaScript. Or it could be accelerated computing. Today's agents are relatively simple users of tools. Tomorrow, they're going to be very sophisticated users of tools, which is the reason why the COMPUTEX libraries that I showed you are going to be incredibly popular with agents. They solve some of the most important problems the world knows. And all of our COMPUTEX libraries are now going to come with skills that the AI could learn how to use. So the COMPUTEX library, some skills, basically a manual, the AI reads it and go, aha, that's how you use it. The ability to use these libraries by agents are going to be incredible. And so the tools run on CPUs and GPUs and large language models. The security harness runs on CPUs and a security processor called a DPU, NVIDIA's Bluefield. The orchestration of all this runs on a CPU. This is the entire harness, and the CPU is orchestrating all of the work. One of the hardest parts is memory. You could just imagine. The working memory is called KV caching. What to remember, compaction, not just compression, but how to retrieve. Do you retrieve structured data? Do you retrieve unstructured data? What is the ontology, the relationship of all of these different data to itself? That entire processing is incredibly complicated. The memory system of AIs is going to cause the storage system to be completely revolutionized. As you could see, every aspect of this computing model, this computing pattern, this new application called an agent, is fundamentally different than the way that applications used to run. A whole bunch of software sitting inside a binary, sitting inside an operating system. This is the reason this disaggregated, this distributed, this heterogeneous computing problem is precisely the reason we built our next generation, Vera Rubin. Vera Rubin is not one chip. Vera Rubin is not a GPU only. It starts with the GPU, but Vera Rubin is incredible. This entire thing is Vera Rubin, from end to end. It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs that I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called DOCA, the security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers, not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle, and it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company, but over the years, we've evolved to become a systems company. You're looking here now for the most complex system, most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You could see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately we're trying to build an entire stack just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure.
想看最完整的新闻内容，记得下载 TVBS 新闻网 APP。